Hello class, welcome to Pre-Algebra Lesson 8.1, which is all about functions. By the end of this lesson, you should be able to determine whether relations are functions and evaluate functions in function notation for the given values. So let's jump into some vocabulary. First of all, a function is a relationship between input and output. Okay, so usually our input is what we call x, and output is what we call y. Okay, so input is x, output is y. And then in a function, there's exactly one output for each input. Okay, so we'll get into that a little bit more in the next couple of slides. But here are some pictures of graphs, and there's also another way to tell if something is a function. And that's using something called a vertical line test, where if you were to draw vertical lines, it only ever hits the graph in one place. Okay, so you can see this line, even though it's not perfect, these each only hit the blue graph once. So this would be a function. And what this function is testing for is to make sure that there's only one output, only one hit for every line or input. Okay, so if I were to draw a straight up and down line right here, you could see I would hit twice, so there would be two outputs. So this is not a function. And then over here, you could see I drew straight up and down lines, and so far it's only hitting once. And then if I look here, you can see that this is an open circle and this is a closed circle. So if I were to draw a straight up and down line here, this would only hit once because that open circle doesn't count. Okay, so this would be the output. Now, if you were to have a graph that looked like this, where you had two filled in circles, so when you went like that, that would be two outputs, and this would not be a function. Okay, so if there were two filled in stacked on top of each other, it's not a function. If it's one open, one closed, it is a function. Okay, so let's practice identifying functions from a table. So from this table, you want to determine whether each relation is a function. Explain. So remember, definition of a function is for each input, there's exactly one output. Okay, so if I look at my table, these are my inputs, these are my outputs. Okay, I see 2 goes to 3, 6 goes to 5, 8 goes to 5, and 2 goes to -3. So I noticed I said 2 for my inputs twice, and I see that they go to two different numbers. So this would not be a function because 2 goes to 3 and -3. Okay, so it's not a function because my input repeated. Okay, so when you're checking a table to see if something is a function, you want to look to see, do any of your x values repeat? And if they do, are the y values different? Okay, so that's how you can check to see if something is a function from a table. I want you to look at this relation and determine if this is a function, and then explain. Good luck. All right, hopefully you said this is not a function because 0 repeats in our inputs, and it goes to an 8, and it also goes to a -1. Okay, so if you have questions about that or the example I did, please be sure to raise your hand, ask for some help. I'm happy to help you. But let's move on to identifying functions from a graph. So this is kind of what I already talked about on that first vocab page. We have something called the vertical line test, which is where you draw those, oops, that was not very straight at all. It's where you draw those straight up and down lines and see, does it hit more than one time or not? So you can see each of these lines so far is hitting more than once. And you should be able to draw a straight line like anywhere on the graph and only ever have it hit once. So you can see, like right here, that hits once, but the rest of the lines all hit twice. So this is not a function. And your reasoning for a graph is it did not pass the vertical line test, or we can call it VLT for short. Okay, so not a function because it didn't pass the vertical line test. Okay, then I want you to look at this graph and determine if this one's a function. Good luck. All right, for this problem, hopefully you said yes, it is a function because it passes the vertical line test, or you could have just written VLT. Okay, if you have questions about that, please be sure to reach out for some help. I'm happy to help you. Let's look at example 3, which is identifying a relation, identifying if something is a function from a mapping. Okay, so the way that you tell if something is a function from a mapping is you can only have one arrow going from each of the numbers in the domain. So right now you can see there's one arrow from -4, one from -2, one from 2, one from 5, and none of those numbers repeat. So this is a function. So you'd say yes, each input has exactly one output. And that would be your reasoning. Okay, but now I'm going to change it up a little bit. Let's say that this also went like that. So you can see that the 5 now has 2 arrows. The domain has a number where it is 2 arrows leaving from it. You'd say no, 5 goes to both 3 and 6. Okay, so if we were to add that green arrow, your answer would be no. If there wasn't a green arrow, the answer would be yes, because each of these numbers in the domain goes to exactly one number. And sometimes students will get confused, and they'll say, but -2 goes to 3 and +2 goes to 3. Is that a problem? And the answer is no, it's not a problem, because we only care that none of the domain numbers repeat. The range numbers can repeat, okay? Just not the domain. So now I want you to look at this example right here, and I want you to determine, is this relation a function? Good luck. All right, for this problem, hopefully you said, yes, it is a function because each input has exactly one output. Okay, so the 1 only goes to the 5 only goes to a -1, and this -6 only goes to -1. All right, now let's practice determining if something is a function based on points. So for the points, you want to make sure that x does not repeat. So it is a function if x doesn't repeat. Okay, so here I see it, my x values are 2, 4, 8, and 4. So I said 4 twice, so this is not a function. 4 goes to both 7 and 13. Okay, because those are the numbers paired with each of the 4s. Okay, and then over here, I see I have a 3, 1, 2, and 5. None of those repeated, so I'd say yes, it is a function because each input has exactly one output. Okay, That's all I have to do for that problem. Now I want you to take a look at this set of points and determine if this is a function. Good luck. Okay, for this problem, hopefully you said the answer is no, this is not a function because -2 repeats, and not a function because -2 goes to both 1 and -7. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. Let's now move on to our last idea for this section. So something called function notation. So this is, sometimes it's just easier to call it like a fancy way of writing y equals, okay? So here you can see, you're probably used to seeing things kind of like this, where it says like y equals something. Over here, you can see that I still have 2x plus 3, but instead of saying y equals, I have f of x equals. And this is, they end up being the same thing. This is just called function notation. So you're going to have to practice writing things in function notation. So all that means is that if I give you this and I ask you to rewrite it in function notation, you write it like this over here. Okay, so that's all that means. And just remember that function notation, it's another way of writing like y equals. Okay, so if I give you the function notation, or the function f of x, the way that you read this is f and then the parentheses, you say of, and then whatever variable's inside there. So f of x equals -2x plus 9. And then what this means, you can see I have f of 4. What that means is instead of writing an x, I wrote a 4. So instead of writing an x, I'm going to write a 4. That means I'm just plugging 4 into the equation. So now I have -2 times 4 is -8 plus 9. So my answer is 1. So I'd say f of 4 equals 1. So all you're doing is plugging in whatever number is inside the parentheses. So in this case, this would be -2 times 3 plus 9. And then you can see outside of the parentheses, they have a plus 4. So that means that you write the entire equation, but then you tack on a plus 4. So it'd look like that. So I have -2 times 3 is -6 plus 9 plus 4. -6 plus 9 is 3. Then I have that plus 4. 3 plus 4 is 7. So f of 3 plus 4 equals 7. Okay, so hopefully that doesn't seem too bad, but I know it can be a little confusing and just look a little intimidating. So if you have questions about that, please be sure to ask for some help. I'm happy to walk through more problems with you, okay? I want you to try this problem on your own. F of x equals -3x plus 2, and I want you to find f of -4. Good luck. All right, for this problem, hopefully you plugged in -4. You said -3 times -4 is +12, and +12 plus 2 is 14. So f of -4 equals 14. If you have questions about that problem or anything else, please be sure to reach out for some help. I'm happy to help you. I hope you have a great day.